All right, so I will, on the test, I will provide these rules. I will not provide this top part. The top part you're going to have to kind of know. It's not anything in that top part that you have to memorize, but you should be able, you should know that by the time I get through. So it says, and what you need to know is that if it's soluble, then we write our net ionic equation. We write the compound apart. We divide it into the positive and negative part, and we put a plus in between. Okay, that's what I mean by apart. So if it's soluble, we're going to write the compound apart, and we're going to do several examples for you today. And while I'm doing the examples, then you'll start to understand what I'm saying when I say apart. I kind of don't really know what I'm talking about, other than I'm saying that's part of what you need to know. And then insoluble, you write it together. Now this is like, when I put sand in water, do you think it's soluble? Does it dissolve? I got some more. Does sand dissolve in water? So it is insoluble. What about sugar? Does it dissolve in water? Yes, so it's soluble in water, but sugar is a special exception. What about table salt? What about NaCl? Does it dissolve in water? So it is soluble, and we would write it apart when we're showing it in water. Okay. What we're doing now. Also, if it says molecular, that means that it's written together. All right, so you come down here and it says write in molecular form. That means write it together. Don't write it apart. And you see molecular form in a couple of places. Ionic form means that we have ions being formed and we write it apart. So those are the things you kind of have to know on your own. Okay? So we're going to look at our solubility rules and we're going to learn to use them. That's the key. We're going to learn to use them. So if y'all have all this written, we'll erase this and start with your homework. Now your homework is on page 1 and page 2. You are to do everything you see on page 1 and page 2 to do. So page 1, I'm looking at number 1, and it's AgNO3. And there's a line to the left of the number, and on that line, I'm going to write either S for soluble, or I'm going to write I for insoluble. Then there's another short line to the right, and on that short line, I'm going to write at least one rule that told me to write the I or the S. Okay? We'll take the new one. Then on the long line, I have something else on the right. So AgNO3. Start with rule number 1. All common salts, and it says right here, that's any that I might give you. I'm not going to give you an uncommon salt. I don't even know what they are myself. So anything I give you, we'll assume is a common salt. So all common salts of group 1 and ammonium. So if it said NH4, NO3, there's ammonium. It'll be soluble. But it doesn't. And group 1, where is it and what's in group 1? The periodic table, the first column. Lithium, sodium, potassium, rubidium, cesium, tritium. Those, if I have that, then they are soluble. There's no exception. It says they're soluble. Period. They're soluble. But Ag is not in that list. So then I look at the second one. All acetates and nitrates. I don't have acetate, but do I have nitrate? Yes. Yes. So it says all are soluble. So I'm going to put an S there. And what rule told me to put an S? Number 2. fill them in your blank. The number 2 comes because I said number 2 rule told me to solve. And there are no exceptions. So if it said all are soluble except, I got to look for the exceptions too. All right? So I'm going to write it down here in this bigger space. AgNO3 yield. Now, when I say write it apart, you're going to mentally divide this into the positive and negative part. I'm going to write them apart. So the positive part is Ag. And one of the most important things you write is a +1. Because that Ag, when it comes apart, is still an ion. You remember the other day we looked at the solution of where we had table salt and the water was pulling the Na positives off and it turned the negative part of the water toward that positive ion, and then it pulled off the chlorine, the negative chlorine, and it turned its positive part to the chlorine and surrounded it and took it off on its own, right? So that's what we're happening here. We put silver nitrate in there, and the water works its magic, and it pulls the silver off one direction and the NO3 the other direction. They don't stay together anymore. So we have a plus. So it's very important that you write that little superscript plus NO3 minus. Any group of atoms that stay together, that are written on your pink sheet together, polyatomic ions, stay together. Okay? So if you recognize NO3 as a polyatomic ion, you're going to see the NO3 on this side as well. So that's called a net ionic equation. Now, if you're taking Chemistry 2 next year, this skill is very important. I will reteach it at the beginning of the year next year, the first 9 weeks, while I'm reviewing, because this is probably one of the centerpieces of the entire year. This sort of thing, where we're talking about net ionic equations, and we do equilibrium, and we do a lot of other stuff. All right, so that's your net ionic equation. You don't really have this little dotted line right here. That's a mental line. Okay? So you don't have to draw that. Do it here. All right, so let's do the next one. The next one, if I always lay my paper down somewhere, I can't find it. Here it is. Ag2 SO4. So we start again, and eventually you will know these rules well enough that you don't have to start with number 1 every time. Number 1 deals with group 1, and I know that Ag is not a group 1. Number 2 deals with acetates and nitrates, and since that's neither, the SO4 is neither, that doesn't apply. All binary. Immediately I see binary, and binary means 2. All binary compounds, 2-element compound, that's not 1, so it's not going to apply. But let's go ahead and figure out what would apply. Group 17, now look at the periodic table. What are the elements in group 17? Chlorine, fluorine, bromine, iodine, and cadmium. Okay? Well, we're not, and it says other than fluorine, are soluble except when they're paired with silver, mercury, and lithium. So if you had something like AgCl, it would not be soluble. Even though the Cl is group 17, the Ag is an exception. All are soluble except silver chloride. Okay? So that would not be soluble. But that doesn't apply either. So number 4, all sulfates are soluble. Except barium, strontium, lead, calcium, and winner, silver. So this is insoluble. All are soluble except those. And number 4 is the one that told me that it was insoluble. That's where I got my information. Now I'm going to write the Net Ionic equation. Ag2SO4 yield. Now what did I say? If it's insoluble, we write it together. So that would be Ag2SO4. So there's no change. They don't come apart. They stay together because they're insoluble. That's like when I put silicon dioxide plant in water. It does not dissolve. But even though we say it doesn't dissolve, most things have an infinitesimal number of molecules that do come apart. But it's so terribly small that we ignore it. This, for example, I don't know what the solubility constant is, but it would be something like if I put 100,000 of those molecules in there, maybe one comes apart, or maybe two out of 100,000. That's not enough for me to say it comes apart. Where a while ago when I had AgNO3, and I put it in water, if I put 100,000 of them in water, if I put 100,000 of them in water, then probably 99.99% come apart. There might be one or two that come. But the opposite. Basically all of them come apart. Where basically all of them don't in the silver sulfate. You understand what I'm saying? There's always some small exception to most of it all comes apart and all stay together. And that's that exception. All right, going to do number 3. Number 3, we have HgCl2, and we need to decide if it's soluble or insoluble. We know number 1 doesn't apply because Hg is not in the first column. We know number 2 doesn't apply because we don't have acetate or nitrate. It is a binary compound, so maybe number 3 applies. So I've got to think about number 3. I can't stop and say, well, it is a binary. And group 17. So when it says group 17, I need to concentrate on the last part of my binary compound and see if it's in that 17th column. Next last column. Fluorine is. So I'm good to go so far, except fluorine with metals. Well, it's always going to be with a metal unless it's a gas or something like that. Are soluble. Now remember, metals are everything this side of the staircase, right? Are soluble except silver, mercury 1. But since I have mercury there, exactly, I have to evaluate, is that mercury 1 or mercury 2? Mercury 2 always has to have a 2 by it with a +2 charge. Is that mercury 1? It is. Mercury 1, say it backwards, mercury 1, look at mercury 1 on your sheet. Mercury 1 always has to have a 2 by. So this has to be Hg2 +2. Is it mercury 1? No. It's mercury 2, so the exception does not apply. And so it is soluble, and the rule that says it's soluble is number 3. Now I'm going to come over here to draw us a picture. Here's my container. I have HgCl2 yield. Hg plus 2. Suppose it was Fe. If it were FeCl3. What's the charge of Fe? 3. I have to be able to go back to where we learned to do this, and we have to know that they'll figure out the charge. So. All right, so here's my water, and when I put this molecule of Hg in here, I have the Hg is by itself, And then one of the CLs floats off over there, and the other one floats off over here. They are nowhere close to each other, so I don't write it as CL2. They are completely alienated and far away. So I'm going to say plus 2CL minus, because the CLs go on their own. Now, when I take a compound like this, unless that subscript is written on your pink sheet, unless that subscript is written on your pink sheet, it has to be a coefficient on this side. Now, I know y'all hear about half of what I say. If I have a subscript over here that's not written on your pink sheet, then it has to be written as a coefficient. I didn't say don't write it, that you can never have a 2 on the CL. I said if you have a 2 on the CL, it's going to be a coefficient on that side. Okay? But if it's something like HG, SO, well, that one won't work. I'm trying to think something here. Say NaClO3, then that one is going to be Na plus ClO3 minus. That 3 is written as a subscript because it's written on the pink sheet with your common solid atomic ion. Okay? So if I looked on the pink sheet and I looked up Cl minus, there is no subscript. So there will be no subscript on that side. I didn't say there would be ever be no subscript. I said there will be no subscript on this side. It will be written as coefficient. I said it multiple times, so maybe those of you who hear half of what I say will hear it both times. And not listen to both. All right, so let's go back here. And now we're going to look at, I'm going to leave you with that work on it. I'll answer questions, of course, on Monday. All right, I'm going to page 2 now. Let's set up a little bit. Now, we've done this before, but when we did it before, we always had that the number of protons, the number of protons was equal to the atomic number, and that's still true, but we did say it was equal to the number of electrons because the charge of the atom was 0. The charge of the atoms, they're now ions, they're not 0 anymore. So this part is not true if you have a charge given. So if you have a charge given, that's not true anymore. We also learned that the atomic mass, excuse me, not the atomic mass, the mass number was equal to the atomic mass, rounded off to the nearest whole number. All right? The mass number is equal to the atomic mass, rounded off to the nearest whole number. Look at copper. Need a periodic table, look at copper. Everybody's supposed to have one. Copper. What is the mass number of copper? 64. The atomic mass is 63.54. So 5 goes up, so it's 64. Now, if I want to know the number of neutrons, let me use the symbol to be a lot easier. The number of neutrons is equal to the mass number minus the number of protons. All right, I want to know the number of neutrons for copper. The number of neutrons for copper. I got the mass number. You told me it was 64. That's the rounded off atomic mass. How many protons does it have? Look at your periodic table. There's another major number on your periodic table. 29. So 64 minus 29, and our number of neutrons then is, your calculators please, 35. So I have 29 protons and I have 35 neutrons. And I have a mass number of 64. Okay? I need to do another one. Enough to refresh your memory. You wrote these notes down, you can replicate this. If you sit there looking at it, hoping you can remember it, I don't think it's going to happen. Y'all can't remember to take sharps out and pick up your shoes out of the living room when Mama tells you to do 2 things. Do one of them, you get the other. Oh, cool. So don't depend on your magnificent memory to remember this. Like it. All right. Do you need any interpretation? All right, now we've got chromium in the first column. Now I'm going to give you a demonstration here, and I'm going to say that these pink sheets I'm holding in my hand are protons. I have 4 protons. I have 4 pink sheets holding in my hand. And they are super glued to me. They cannot be taken away. If they are taken away, I am no longer beryllium. Which one of the elements has 4 protons? Periodic table. Beryllium. If something comes along that's powerful enough to get rid of one of my protons, how many protons do I have left? 3. What element am I? Lithium. I am no longer beryllium. I have changed my entire character because I've lost the proton. So chemistry does not deal with protons. It deals with electrons. Electrons can be swiped off really easily and given away. Now, what's the charge of a proton? Positive. What's the charge of an electron? Negative. Now, these pins that I have in my hand represent electrons. I don't care how many neutrons I have. It has nothing to do with my charge. But I have 4 protons, which is a positive what? 4. I have a positive 4. I have 4 electrons, which is a negative 4. So my total charge is 0. Now, I can give away electrons pretty easily. I don't want 2 of them. They're like redhead stepchildren. I'm going to give them away. I don't want them. I'm going to throw them off somebody else that does. So I'm going to throw away 2 electrons. Get them over here to this table. I have 2 electrons left, but I can't throw away these protons, or I won't be beryllium anymore. I'll be something weird. And I want to be beryllium. So I'm not going to do anything with these. So what's my charge now? I have 4 protons and I have 2 electrons. Positive 2. But look what I did. I gave away something and I got a positive. I gave away electrons and I got a positive. You see where I'm going here? I gave away something and got a positive charge. Now, we'll pretend, although beryllium does not ever want to gain electrons, we're going to pretend for a second that it walks by and it steals an electron from somebody. Okay? Now, how many electrons do I have? 5 electrons and 4 protons. I have gained an electron. What's my charge? So when I gain electrons, I get a negative charge. When I lose electrons, I have a positive charge. So on your sheet, or on just something somewhere, you need to write gain electrons, get negative charge. Lose electrons, get a positive charge. Okay? Now, it sounds weird to lose and get positive, and gain and get negative. It sounds backwards. It is. If I gain money, I usually am positive money. If I lose money, I'm negative money. But electrons, remember, we are minusing minus electrons. I minus some of those minuses I had in my hand. And minus a minus is a positive. So when I minus a minus, I get a positive. When I plus a minus, I get a negative. Electrons are always minus. All right, so let's look at what we've got here. We got chromium. I need the number of protons. What do I need to look at? Periodic table, and I'm looking for the atomic number. Periodic table, chromium atomic number is what? Say it loud, I didn't hear you. 24. Now remember, mentally, or you can write it down, that's a positive 24, because every proton has a positive charge, so it's positive 24. Neutrons are neutral. And how do I find my neutrons? Mass number minus protons equal neutrons. So what's the mass number for chromium? So I have 52 minus 24 equal, now here I'm just putting it in the formula. The minus has nothing to do with the charge of the proton, of the fraction. And so I get what? 28. So I have 28, and those have no charge. It's just 28 things that give me more weight. Now I need to know the electron. It's not 24. That's right. Here's what I want you to visualize with me, though. I have protons minus electrons equals the charge. What's the charge of the CR? Plus 3. It's written right there. We know that's the charge. We've been seeing those charges on that pink sheet for a month. So my charge is plus 3. So what do I have to add to 24 to give me a plus 3? 21. Minus 21. I'm going to put a minus out there just so I remember that everything that's in this column of electrons are minus. Everything that's in the not column, everything's in this row of protons are positive. So you can write it or not write it, I don't care. But you do have to realize that whatever number you put here, added whatever number you have here is going to give you that last number. Okay? Whatever number I put here, plus this minus that I put here, will give me this answer. Okay? So what I do here, I said plus 24 minus 21 equals 3. So I'll have to know what the atomic number is for 10. I'll have to know what the charge is, which I get from up there. And so you're going to be doing that. All right, any questions? Yep. Charge is what? It's down here. Written right here.